Welcome and thank you for joining. In this lesson, we'll explore adding and subtracting rational expressions. Recall that to add or subtract fractions, we need to make denominators the same as the lowest common denominator. Similarly, when we add or subtract rational expressions, we need to make the denominators the same as the lowest common denominator. Recall that to find the lowest common denominator means to find the lowest common multiple of denominators, which means that it's going to be that number or that expression that is equally divisible by all the denominators. And by equally divisible, we mean that when lowest common multiple divides into each denominator with no remainder. So in rational expressions, denominators will be in polynomial form. So I thought it is better that we start with how to find the lowest common multiples in polynomial expressions. So we're going to start with a simpler example. So we have 3a minus 9 and 4a minus 12. And we need to find the lowest common multiple of this set of expression. So step number 1, we would list both of them one after the other, and we will write the factored form of it. So 3a minus 9 is 3 times a minus 3. Then right below it, I'm going to list the next expression, polynomial expression, and we see that 4a minus 12 is 4 times a minus 3 in factored form. Notice how I aligned the common factors, a minus 3, together, and for numbers 3 and 4, which are factors of respectively 3a minus 9 and 4a minus 12, I assigned a specific spot. Now, to find the lowest common multiple, what we do is we multiply all these, let's call them prime factors of the expressions. So that would be equal to 3 times 4 times a minus 3, or even better, 12 times a minus 3. Let's move on to the next example, and you can try this on your own if you wish. It's very similar to what we just did. So again, here we have 2y minus 6, y squared minus 9. We'll start with 2y minus 6 and write it in factored form, completely factored form. So 2y minus 6 will factor into 2 and y minus 3. Y minus 9, y squared minus 9, on the other hand, is y minus 3. So notice how we align the common factors, because we don't have to list them twice in the lowest common denominator or lowest common multiple. And then the other factor is y plus 3. So this deserves a new spot because it's a new factor. Now, the lowest common multiple of these two expressions would be equal to number 2, and then multiplied by y minus 3, and then multiplied by y plus 3. Now, 2 times y minus 3 times y plus 3 will be divisible by 2y minus 6, which is basically 2 times y minus 3. So it will divide evenly, and then you will have y plus 3. So this will allow us to simplify at the end when we need to. And y squared minus 9, which is y minus 3 and y plus 3. And that's the idea of the lowest common multiple. So to divide evenly in each expression. Let's do one more example. This time we have x squared plus x and 2x squared plus 2x. So we're going to start with x squared plus x. We'll write it in completely factored form, which is x times x plus 1. Now, 2x squared plus 2x, on the other hand, would be factored into 2 times x plus 1. So the lowest common multiple then would be equal to, we bring number 2 down, we multiply by x is common as you can see, and that's why we list them right below each other, times x plus 1. So again, this lowest common multiple divides evenly into both expressions. One more example. We have x squared plus 5x plus 6 and x squared plus x minus 2. So we'll start off with x squared plus 5x plus 6. As you see, we have two trinomials. So x squared plus 5x plus 6 in factored form is x plus 3 times x plus 2. On the other hand, x squared plus x minus 2 is x plus 2 times x minus 1. So notice how the common factor, again, we align them, so we count them once in the lowest common multiple, and then the factors that are not the same will deserve a special spot. So the lowest common multiple of these two trinomials would be equal to, we bring x plus 3 down, now we're going to bring x plus 2 down, and then times x minus 1. And again, this is divisible by either expression. And if you have polynomials of higher degree, which we don't know, we don't do at the moment in grade 11, in principle, we follow the same strategy. So we're going to list the factors, the prime factors of each polynomial, and all the common factors right below each other, so they count only once, so we won't make the lowest common multiple bigger than it should be. So I hope that this made sense. Thank you for learning with me. Bye for now.